what is the formula of porosity? Ekta brishti
The
speed plus.
bulk density by 2 density.
No.
তাহলে তুমি কি ওই 1 - কি ওটা
Exactly,
জানতে
yeah,
চাইছো?
that is the formula, right? Formula. Yes.
তো মানে ওটা হচ্ছে 1 - ট্রু ভলিউম বাই বাল্ক ভলিউম।
Hmm. This is the formula, right? Porosity. True volume by bulk volume, that is okay. PL, I think তুই এটাই বলছিলিস তাই তো, bulk true volume, sorry, void volume divided by bulk volume. Okay, that is true. Void volume by bulk volume, that is the formula. But basically in the questions they will not give you that term. I mean all the things they will refer like true volume T and the bulk volume. They have mentioned all those things, and from that you have to calculate the porosity, and obviously it will be in percentage formula. I mean into 100. Okay, so that is the porosity formula, right? So anyway, so if you just follow this kind of equation and formula, then one thing you have to remember, I mean that is one, I mean static information. Okay, static information, that is the for rhombohedral or closest system. Like you can see here, what is rhombohedral? Obviously that is 2D representation, but I can remember I have told you that if you, I mean imagine like a 3D structure, rhombohedral, so there the total porosity will be 26 percentage. And if you consider one cubic packing, cubic matlab that is also a 3D cubic, so for that reason 48 porosity. So you can just visualize very easily that for the case of cube the porosity will be more. I mean you can consider like the volume will be more. Okay, void volume, all these things. Okay, for a cubic packing. Okay, 48 percentage and 20, and all those things, I mean the equation, and I mean the 26% porosity, 48 percentage porosity, those are actually required. You can consider like different tablet punching phenomena is there, like compaction, compression. Okay, so there this kind of calculation is there. I mean what should be the tablet I mean the punching diameter, and lot of consideration is there. So just remember, for the competitive exam point of view, don't need that much of deeper sense. There only that cubic packing or loosest packing, I mean loosest packing, that is 48 percentage porosity, and lomboidal 20. Okay, that is enough. Okay, so now flow properties, I mean you have just little bit, you have to know that which kind of property, मतलब कौन सा property है कि that is actually affect the flow property. Flow property from pharmaceutical point of view, that is basically during the tablet punching. Okay, if you consider that what happened, there is a tablet punching machine is there, if you consider. Okay, and tablet punch lower and upper punch is there in every, that is called actually the turret. Okay, lower punch, upper punch is there, and you can see, I mean one hopper will be there. Okay, hopper, so you can just put and you can give the granules in the hopper, and from the hopper the granules will come, and in every, I mean कंपार्टमेंट मतलब एक एक कंपार्टमेंट में एक टैबलेट होगा, और बाई लेयर टैबलेट भी हो सकता है, ठीक है ना. दैट इज एक्चुअली डिफर्ड, आई मीन इन वेरियस केसेस. बट फ्रॉम हॉपर द ग्रैन्यूल्स विल कम, and the granules will fill in the every compartment. I mean where the punch, not the compartment, that is the punch, lower punch, upper punch. So during that, from the hopper to the punch, okay, so that flow property of the granules of that particular material, ठीक है. So that is actually depends upon different types of phenomena. You can consider like the size, shape, porosity. So particle size, obviously if it is not, I mean that kind of fine particle, ठीक है ना. coarse particle होगा तो obviously उसका flow property अच्छा नहीं होगा, ठीक है ना. fine particles improve the flow, that is very basic things. and और भी थोड़ा मतलब पॉइंट है, लाइक हाइग्रोस्कोपी, इधर पे मेंशन नहीं है कि पता नहीं मेरे को, बट हाइग्रोस्कोपी मैंने बोला था. हाइग्रोस्कोपी मीन्स द एबिलिटी ऑफ एनी कंपाउंड to hold the moisture. Okay,
To attract moisture, moisture
yes,
attracting,
yes,
moisture attracting.
yes. So if one powder is there or any material that is, I mean too much hygroscopic in nature, so what happened, obviously the particle will try to agglomerate due to the excessive moisture. So they will form, the concept you will not, I think, hard, like first of all they will form some kind of liquid bridge. Okay, लिक्विड ब्रिज, मतलब दो पार्टिकल का है उसके अंदर एक लिक्विड का ब्रिज बॉन्डिंग हो जाएगा, ठीक है ना. लिक्विड ब्रिज एंड ऑल दोस थिंग्स ऑब्वियसली, आई मीन लीड्स टू फॉर्म वन काइंड ऑफ एग्लोमरेशन. तो एग्लोमरेट हो जाता है, मतलब क्या है, पार्टिकल साइज भी बिग हो जाएगा. एग्लोमरेट मतलब क्या होता है, एक साथ जुड़ जाएगा सारे पार्टिकल, ठीक है ना, एग्लोमरेशन। सो उस केस में भी थोड़ा प्रॉपर्टी मतलब फ्लो प्रॉपर्टी थोड़ा पुअर हो जाएगा, ठीक है ना। तो इसलिए ऑप्टिमम एक मॉइस्चर्स कंटेंट उसमें रहना जरूरी है, ठीक है ना। सो वो एक फेनोमेना है। और नेचर ऑफ पार्टिकल तो स्मूथ ये वाला ऑलरेडी मैं बोल दिया, ठीक है ना। सरफेस मतलब सरफेस जो होगा उसको जितने तुम मतलब स्मूथ बनाओगे, मतलब फाइन पार्टिकल को होगा, तो उसका फ्लो प्रॉपर्टी भी अच्छा होगा। रफ होगा तो ऑब्वियसली लॉट ऑफ फ्रिक्शनल फोर्स, ठीक है ना, फ्रिक्शनल फोर्स विल बी देयर। और उस जिस टाइम हपर से जाएगा उस टाइम भी उसके अंदर फ्रिक्शनल फोर्स जनरेट होगा। इसलिए तो हम लोग ग्लाइडेंट लुब्रिकेंट, अच्छा व्हाट इज द डिफरेंस बिटवीन द ग्लाइडेंट एंड लुब्रिकेंट, दैट इज ऑल्सो वेरी बेसिक थिंग्स। लुब्रिकेंट एंड ग्लाइडेंट, वेरी बेसिक थिंग्स। ग्लाइडेंट जनरली हम क्यों देते हैं और लुब्रिकेंट क्यों, और उसका काम मतलब स्पेसिफिक एरिया मैंने जो बताया इधर पे एक मतलब क्या होता है, प्रॉपर एक टैबलेट पंचिंग स्टेशन होता है, उसका टारगेट बोलते हो, ठीक है ना। अपर पंच लोअर पंच एक कंपार्टमेंट होता है, और ऊपर एक हॉपर होता है, ठीक है ना। हॉपर से आता है ग्रैनुल्स और इसमें जाके अपर पंच लोअर पंच एक साथ मतलब उसका एक फोर्स उधर पे अप्लाई होता है और टैबलेट पांच होके निकलता है। ऐसा ही तो होता है ना, इजेक्शन कैंप भी है। बट मेरे जो कहने का मतलब है, जो ग्लाइडेंट और लुब्रिकेंट वो स्पेसिफिक उसका देखो काम उसका लगभग सेम है कि थोड़ा फ्रिक्शनल फोर्स को कम करके उसको फ्लो प्रॉपर्टी अच्छा करनी है, तो ठीक है। बट स्पेसिफिकली किधर यूज होता है ये तुमको या कुछ आइडिया है, ग्लाइडेंट और लुब्रिकेंट?
যাদের গ্লাইডেনটা
Sir,
হচ্ছে ফ্লো
Glidant
প্রপার্টিটাকে ইনক্রিজ করে ইমপ্রুভ করে, আর লুব্রিকেন্টটা হচ্ছে যে ট্যাবলেট আর ডাইভেল যেটা থাকে সেই দুটোর মধ্যে ফ্রিকশনটাকে কম করে।
ওকে, বাট অ্যাকচুয়ালি স্পেসিফিক এরিয়াটা তাহলে কোন জায়গাতে হলো এটা আমি একটা ক্লিয়ার হল না। ইফ ইউ সে
গ্লাইডেন্ট ওই আপার পাঞ্চের পিক যাতে না করে ওই জন্য কি গ্লাইডেন্ট হেল্প করে, আর লুব্রিকেন্ট হচ্ছে হপার দিয়ে যাতে গ্র্যানিউলগুলো প্রপার ফ্লো
নো
করতে পারে, আটকে না যায়।
ইউ অ্যাকচুয়ালি টোল্ড, আমি ঠিক অপর তুই একটু উল্টোটা বলে ফেলেছিস। লুব্রিক্যান্ট অ্যাকচুয়ালি গিভ to prove, I mean the optimize or I mean increase the flow property or improve the flow property inside the lower punch और upper punch, ठीक है ना। टारेट में जो होता है ना टैबलेट पंचिंग के मतलब दौरान। बट ग्लाइडेंट एक्चुअली इम्प्रूव द फ्लो प्रॉपर्टी इनसाइड द हॉपर, मतलब हॉपर के साथ जो फ्रिक्शनल फोर्स होगा वो थोड़ा इम्प्रूव करेगा ग्लाइडेंट, ठीक है। और लुब्रिकेंट एक्चुअली वो जो अपर पंच लोअर पंच इसके अंदर जो उधर पे भी बहुत सारा फ्रिक्शनल फोर्स, रेडियल फोर्स, ठीक है ना, बहुत सारे फोर्स होता है। और वो सारे फोर्स मिला के एक्चुअली अल्टीमेटली टैबलेट पंचिंग का जो मैकेनिक्स होता है वो होता है, ठीक है ना। तो लुब्रिकेंट हम लोग इसीलिए देता है कि वो टैबलेट पंच के टाइम उसका फ्लो प्रॉपर्टी और ऑल दोस थिंग्स एक्चुअली हैपन वेरी स्मूथली, ठीक है। बट ग्लाइडेंट उसका जो काम होता है जनरली हॉपर से जो जब आता है वो जो ग्रैनुल्स उस टाइम उसका फ्रिक्शनल फोर्स को कम करने के लिए ग्लाइडेंट देता है। बात समझ में आया कि नहीं है बोलो? ग्लाइडेंट और मतलब গ্লাইডেন্ট
ভুলিয়ে গেছি।
এটা পিএল এটা বুঝতে পারলি কি না, কোনো কনফিউশন আছে? গ্লাইডেন্ট জেনারেলি হপার, ওকে, ইয়েস।
আর লুব্রিকেন্ট ওই আপার পাঞ্চ আর লোয়ার পাঞ্চ
Exactly. Okay. Lubricant means always it will works generally inside the पांच डाई, उसको डाई भी बोल सकते हो, ठीक है ना। जिधर पे टैबलेट का पांच होता है उधर उसको तुम डाई भी बोलते हो। सो वो जो डाई और पांच होता है ना, डाई और पांच टैबलेट पंचिंग का जो मशीन होता है तुम उसको देखे हुए, तो वो जो डाई और पांच एक मतलब अपर पंच होता है और एक लोअर पंच होता है, ठीक है ना। तो उसके मतलब वो जो लुब्रिकेंट है ना उधर उसका काम उधर होता है, मतलब फ्रिक्शनल जो फोर्स होता है उसको कम करते उधर। बट ग्लाइडेंट जो होता है वो फ्लोएबिलिटी को इंक्रीज करता है किधर, जनरली वो तुम्हारा जो हॉपर होता है, ठीक है ना। बात समझ में आ रहा है कि हेलो, ठीक है। सो तुम इजी वे में ऐसा भी तुम बोल सकते हो कि ग्लाइडेंट का काम ऐसा है कि वो फ्लो प्रॉपर्टी इंक्रीज करता है, ठीक है ना। फ्लोएबिलिटी और फ्लो प्रॉपर्टी इंक्रीज करता है। और फ्लो ऑब्वियसली किधर होगा, ये तो कॉमन सेंस है, फ्लो किधर होगा, ऑब्वियसली वो जो हॉपर होगा उधर से ही फ्लो होगा ना, ठीक है। वो है ग्लाइडेंट का काम। और तुम्हारा फ्रिक्शनल फोर्स के साथ रिलेटेड कौन है, तुम्हारा लुब्रिकेंट, ठीक है। तो फ्लो प्रॉपर्टी इंक्रीज करता है तुम्हारा ग्लाइडेंट और फ्रिक्शनल फोर्स को रिड्यूस करता है वो है लुब्रिकेंट, एफएल, ओके, ठीक है ना। समझ में आया ना चीज? हेलो
হ্যাঁ দাদা।
एवरीवन, हेलो एकता, खुशबू,
Yes, sir.
Okay, okay. Just wait for a few minutes. I just want to see how many you have joined, because sometimes it's really important for us to monitor. Okay, it's actually taking time. I will see later. Right. Okay. So now that is the percentage compressibility. So compressibility. Hello. Anyone say anything? Okay. The things is that compressibility compression मीन्स क्या होता है बोलो. वो जो compressibility मतलब वो जो ग्रैनुअल्स होता है, ठीक है ना, ग्रैनुअल्स जो होता है उसको तो हम अल्टीमेटली एक टैबलेट का रूप देता है ना ग्रैनुअल्स. तो ग्रैनुअल्स से जो टैबलेट जो होता है, ऑब्वियसली उस केस में उसका मैकेनिज्म बेसिक प्रिंसिपल क्या होता है, तो कितना कॉम्प्रेस हो
Sir,
रहा है. हेलो. यस यस.
sorry to interrupt the class. Sir, can you explain in English? My friend Ditish has joined this class. He's the first class. That's why I'm saying.
Okay, okay. Just try to just he's I mean trying to say to communicate on to just lecture, giving the lecture in English, right?
Yes, sir. Yes, sir.
Okay, okay. Got it. Okay, okay. The things is that is the compressibility. Okay, compressibility means what happen. You know, I mean I have already told that tablet compression. Okay, tablet compression in the particular phenomena what happened from granules. Tablet is actually forming, right? So, but the basic phenomena you have to understand the volume. ठीक है ना, granules if you consider lot of void volume, bulk volume, different types of void space we have discussed right in the previous class, intraparticulate volume, in interparticulate volume, all the things will be there, right? So basically what happened when the force will be applied, from upper punch, lower punch, even the radial force, if you assume like I've just tried to draw it little bit, that is the upper punch, okay, that is the lower punch, and if you say this is a total dry compartment, okay, dye punch or dye compartment, so this is the space where actually tablet first granule will be there, this is the place, okay. Let me just use different color, yeah, that will be fine. This place, try to understand this place. First of all, what granules will be there at the very beginning, but lot of force like some axial force from the upper punch, radial force, okay, radial force will be there, or frictional force also I have say, right? But our motto is to reduce the frictional force, but the things is that lot of force will be there on the granules. So due to that, the void space that is actually present in the the granules, that will reduce, ठीक है ना, that will reduce, and ultimately from granules tablet will be get shaped, okay. So the things is that all the void spaces that will be diminished or decreased, and one compact. So that's why I've just say the term compaction. So compact will be there, okay. Compact form means the volume the void space will be decreased. So how much or how extent one particular the compound or material can compress, or it can reduce its particular void the void space under the influence of any kind of force, that is the compressibility, the ability to compress. That is the basic things, okay, the ability to get compress. After compress it will form one compact product. In that particular compact product, the volume or any kind of void space will be decreased, okay. So that is the basic concept of compressibility, ठीक है ना. But compressibility you can get some kind of idea obviously with the help of Carr's index. Different value is there, and the formula is tapped bulk density minus untapped or altered. You can just normal remember like a untapped means tap density, bulk density. You have already done the practical, right? Tap density 100 times you have to give into the particular type of the machine, but it will get totally compact. Tap density, you have done the practical, na? 100 times generally actually generally yes, tap density. Yes, so the formula is that initially what is the density, before tapped, okay, and after tapped it, like it is actually 100 times if I not say it wrong. So after that, what is the final density, Okay, first of all you have to determine the volume. From that you can just determine the density, because you know the mass. Okay, so first of all you have to calculate the volume. So from that you can determine the density. So if you have that particular data, you can determine the compressibility. Okay, so that is the things, compressibility. And now the Kar's index value is there. Okay, so those things actually you have to remember, because the one thing just you can see normally, that the least the Kar's index, the excellent will be the flow the flow property. Okay, Kar's index or percentage compressibility, if it is less, so the flow property will be high. So that is the basic things. Okay, why this is like that, because after compression or compressibility, if it is very low, so you can think that obviously it can flow easily. It can flow easily, because after compaction or compressibility, it will be totally get rigid. Rigid matlab you can understand a rigid, it means it will be get totally static. Okay, so that is the things. If the compressibility is very high, so it will get into a rigid particle, so flow property will be extremely poor. So try to understand. So normal pounder is there, or you can consider normal granule is there. Okay, so their compressibility is very low, because we have not give or applied any kind of force. So in that particular case it can flow easily. But when you actually give the force, all those force, radial, axial, ठीक है ना, so then it will get compressed. And after compression, so you can obviously imagine one tablet is there and normal powder is there, which one will be flow better? So obviously the powder, ठीक है ना. So that is the basic concept, that if it is more than 40, okay, so extremely poor or cohesive powder. Okay, so that is the Kar's index and percentage compressibility formula, and you have to remember. Okay, actually one tricks is there, but I don't know how much extent you can remember the tricks, because this kind of tricks and mnemonics actually depends person to person. It may be beneficial or easily memorizable for me, but it may not be applicable for you. Okay, but you can just little bit focus that I have just written it like that way. Actually it was not developed by me, I just saying it frankly, because I don't like to take the credit. I say it, so I have just taken it from different places. But the thing is that it is actually, you can remember that excellent, good, fair or possible, poor, these are the phenomena, or these are the property, right? You have seen it multiple times, those who are in third year or final year. Okay, now the things is that they have just write one line, that evergreen field is pharmacy, everyone should join it. So by the every beginning letter, like ever matlab excellent, green good, field is fair or possible, pharmacy is a poor, every, so V is there, very poor, and after that very poor means after that very poor will be there. So that is the phenomena they have written first with the help of that particular line. Then one particular things you can follow, that compressibility 5 to 15 is there, 12 to 16, they have actually like given you some kind of number system or ascending order. Okay, the +7, +6, +5. So you can just consider like that. +7 मतलब ये जो sorry, +7 means 7, 5 plus 7, that is the plus 12, and then +6, 12 plus 6 मतलब 18, and then 5, 18 plus 5 मतलब 23, then 10 and 7 मतलब first +7, +6, +5, 7, 6, 5, then little bit different, odd, like 10 and 7. So that's why I'm just telling you, I don't know that how much extent you can remember that thing. So at least you should remember that it will start from 5. So if you remember at least that, so obviously then it can be easy, like +7, +6, +5. So +7 matlab then the good will be +2, matlab 12, then +6 that will be 18, +5 23. So that much you can remember. And after that +10 and +7 is there, that you, how much. Yes, hello.
This is breaking, sir.
Okay, again the problem is starting. So my voice is breaking from which time? Is recently it is breaking or from the very beginning? Can you confirm?
Definitely, sir. You just start the mnemonics, right? Then that time it will break.
Okay, got it. Okay. Okay. No, it's actually the data is there. I don't know. Okay. maybe little bit problem is there, just try to understand. So that is the basic mnemonics. Okay, if you just try to remember, you can remember by this way, because mnemonics I cannot be explained. Okay, you can see it, and if you can just try it by your own. Okay, so should I pass this? You can just remember it, na? Hello.
Yes, sir.
Okay. So after that, one types of phenomena that by which you can determine the flow property. Okay, that is the Hausner ratio. So those all are derived property. So the very first class I have discussed some fundamental properties, and along with some derived properties. So these kind of things, I mean the Hausner ratio, Kar's index, those are actually derived properties, because you have to know the volume first. So if you have any kind of, I mean the idea of volume, so from that you can determine the density. Okay, and from the density you can determine this kind of phenomena. Okay, that will obviously implies, or that will signifies the different types of flow property. So Hausner ratio also, good flow matlab less than 1.25, and 1.25 to 1.525, that is the moderate, and more than 1.5, that is the poor flow. So only you have to remember the data, because in questions in every year they will try to give the questions from here, and if little bit exceptional is there, so that is different case, but they actually ask you the data, that which one is the moderate flow, good flow, that is the things. Okay, so Hausner ratio, that is the tap density by bulk density. Okay, so Hausner ratio is important because also it can, I mean, affect the uniformity of dose, because uniformity dose means what? I mean, paracetamol 650 mg is there. When you will study the tablet, you will study that according to IP and USP, different regulatory bodies, some types of weight variation is there. I mean, they will apply, or they will just consider some extent of weight variation. Okay, it's not like that 650 paracetamol 650 mg paracetamol tablet is there, in some tablet 30 mg excipient is there, some tablet 200 excipient is there, some tablet 210 excipient. It's not like that. Okay, so uniformity should be maintained. Uniformity and API and uniformity both should be maintained. If one industry produce 1 lakh tablet per day, so uniformity according to IP and USP plus minus 10 or plus minus 7, all these things are there. So you have to follow that. Okay, out of that range if you go, so obviously the total batch will be failed. So for those are the phenomena for which this kind of flow property you have to consider. Like if the flow property is not proper, so you can consider, or you can just easily understand that through the hopper the appropriate amount of granules will not come down in the punch die, right? So if the flow property is not that much good, I mean it is not, if it is very poor or moderate, so obviously in a particular time, like you can consider, if you see the tablet punching machine, so within a very few fraction of second all the process is actually happening there. So if the flow property is very poor, you can understand that instead of 300 mg of excipient, only 250 will become, and the that punch, all the punch or turret will be just goes out. Not the turret, the die will be goes out or goes away from the particular, the hopper side. Okay, so particular powder or granule that will not able to flow. Totally what you can say, like filled. So if it is not filled the optimum amount or uniform amount, so tablet will be obviously defective in a way. Okay? So for that reason the flow property should be maintained properly. Okay, and for that reason different types of evaluation tests. So evaluation test means those, if you try to formulate in one tablet, got my point or not? If you try to formulate any kind of tablet, it may be dispersible, enteric coated tablet, or any kind of normal you can see like immediate release tablet or sustained release tablet, any kind of tablet it can be. If you try to evaluate on formulate one tablet, in the evaluation test you have to determine all the things, Kar's index, and after that Hausner ratio, and from that you have to optimize your product or granules, so that is always try to at least good flow. It may not be excellent, it's not possible all time. If you try to formulate one tablet in normal lab level, it may not be excellent in every case, but at least good flowability should be maintained. If it is poor or very poor, and if you make the tablet with that particular granules, it is totally worthless. Okay, it will actually failed. So that is the concept, Hausner ratio and all those things. Okay, And angle of repose, the same things. Okay, regarding angle of repose, I want to mention you one thing, because that is very common to you, because you know, okay, if it is like that, angle theta, so you know height by radius or height by base, anything you can consider, that is the angle theta, right? So from that you can just determine the angle of repose. The practical also you have did. We actually taken one kind of funnel, we actually taken the funnel and we give the powder or granules, so the heap or any kind of pile that will form, so from that you can determine the angle of repose. Okay, so in the graph paper, what happened, in the you have to take some kind of scale and you have to measure the height first, what is the height of the pile, and generally we taken the graph paper, right? On the graph paper we actually, I mean, let the all the powder to flow or any kind of the piles is actually formed on the graph paper. Okay, so what is the advantage of the graph paper? From there you can just get some kind of circular place. Okay, so you can just determine the radius. Okay, if you just try to get the circle, or if you try to, I mean, if you get the the circular structure from that particular pile of powder, so you can obviously easily calculate, I mean, understand, or you can, I mean, calculate the radius, right? So radius and height if you get, so from that you can determine the tan theta or theta value. Okay, so according to the theta value you can just determine all those things. Excellent, good, possible, food. So general, what is the general idea? So you just try to say, if the theta angle is more or theta angle is less, what it actually implies? If the theta is more means what? If the theta is less, then what? Try to just give me the answer. Normal idea, theta is more or theta is less, what will be the, I mean, the case? Theta is more means
থিটার
what?
অ্যামাউন্টটা কম হলে তাহলে বলবো
Yes, হ্যাঁ,
থিটার ভ্যালুটা বেশি হলে হচ্ছে যে অ্যাঙ্গেল অফ রিপোজ হচ্ছে কম, মানে থিটার ভ্যালু বেশি হলে আর থিটার ভ্যালু লেস হলে
one by one. I just want to know, not the angle of repose, all this concept. I just want to know that theta high means it implies what? I mean, the powder actually gets some kind of obstacle, or its the flow is not smooth. That's why it cannot disperse or oily. Acha, who is saying? Said, you are saying something, because your voice is not properly audible to me. Hello, Said,
Yes, sir.
you are saying something?
No, sir. So I want to say, like, if theta is less, flow property is very good, excellent. If theta is high, flow property is very
I
bad,
just
sir.
want to know the reason. I mean, your basic idea or basic visualization or observation. I just want to know that. Theta high, theta low, that concept I know, but I just want to know the basic idea. Like one pounder, if the flow property is not well, so what happened in that case? So obviously, I mean, I just want to know that things only. Okay. Okay, I'm just.
Sir, it does not.
Yes. Tell.
Sir, if the flow property is not good, means the powder does not slide over to the side, sir. It will
Yes.
act one over the another.
Yes, that will form the more stiffness pile. Yes, if the flow is very well, so it will just disperse. I mean, disperse uniformly in every place, right? It will properly disperse. Try to understand. It will properly disperse or every direction, right? But if the flow property is not very well, try to understand, visualize. It will slowly, I mean, just comes out under the gravity, influence of gravity. So it will just form one heap or pile. Okay, so that is the things I want to know. If the flow property is very well, smoothly it will come, and you can see properly it will disperse on the plane, on the surface, right? So obviously the theta will be very less. But if the flow property is not well, it will come slowly, so you can see also, then one heap will be formed or pile will be formed, right? So proper dispersion or proper, I mean, this kind of things will be not happen on the surface. So then the theta will be obviously high. So that basic, I mean, understanding I just want to know. Now this is clear or not? মানে যারা আছিস বাংলা থেকে, তোরা বুঝতে পেরেছিস আমি যেটা বললাম? যখন ফ্লোটা প্রপারলি হচ্ছে, দেন ওটা ভালো করে সারফেসের উপর স্প্রেড ডাউন করে যাচ্ছে বা ডিসপার্স করছে, স্প্রেড ডাউন করছে। তো স্প্রেড ডাউন করলে দেন অ্যাঙ্গেল উইল বি অবভিয়াসলি লেস। বাট ইফ ইট ইজ ভেরি পুয়ার ফ্লো প্রপার্টি, তখন কি করছে, তখন ওগুলো পাচ্ছে না, তো তাহলে অবস্টাকেল ক্রিয়েট করছে। তাই স্লোলি এসে এসে ওর একটা পাউন্ডারের হিপ বা ট্রাইঙ্গেল টাইপসের, নট দ্য ট্রাইঙ্গেল, দিস কাইন্ড অফ পিরামিডাল ইফ আই সে, পাইল তৈরি করছে, মানে প্রপারলি স্প্রেড হতে পারছে না, তাই অবভিয়াসলি অ্যাঙ্গেলটা বেশি। হ্যাভ ইউ আন্ডারস্টুড অর নট? জাস্ট লেট মি জাস্ট কনফার্ম। হ্যালো?
Yes, sir. Yes, sir.
Okay, okay, okay. Acha, few things is there like that is maybe the area of questioning, that tilted box method. Generally we use the fixed cone or any kind of funnel we actually taken, but except that also these things you have to remember: tilted box method and rotating cylinder method and fixed cone method. Okay, so those three are there. Acha, do anyone have any kind of idea regarding what is the difference between the tilted box method and fixed cone method? Little bit difference is there, not that much, but still.
Tilted box কি একটা বক্স বা শোরুম থেকে ভাইকে টিল্ট করে,
Actually I have not given
কোনো একদিকে টিল্ট করে ঢালছে।
tilt means that is, but matlab I have to give the product or give the any kind of sample little bit slide, make some kind of angle, tilt, some angle will be there, right? Okay, I'll actually add the picture here, so that will be easy to remember the understanding for you. Okay, the picture actually I don't have, that's why. Okay, if I get the picture I will give here, then I can explain. Okay, tilted box means that is the things only. One box will be there and you have to hanging it and you have to tilt little bit, then the pounder will flow and that will obviously form the same heap. Okay, so that is the tilted box method. One box will be there that have to be tilted in a certain amount of angle. Okay, and then the pounder will be make some kind of heap or any kind of pyramid like structure, or you can consider the theta. Okay, so that is the method of angle of theta determination, or angle of repose, angle of repose. So now the different types of the value is there. Angle of repose, if the angle is very low, I have already discussed that will be the excellent, and if it is below, more than or beyond 40 degree, so very poor. Okay, actually in questions they will not give you the least value or the highest value, they will try to give you the the data in the mid to confuse you. Okay, so that's why you have to remember everything, and I will suggest just make the mnemonics or tricks by your own, because tricks or mnemonics always works that you actually made by yourself. Okay, for the now last topic from Micromeritics, that is the grades of pounder. Anyone saying anything? Okay, that is the grades of pounder. Grades of pounder means sometime you can hard like starch 22, lactose 85, so means that starch, lactose, all these product is actually pounder in nature, right? So that is the the value, or that is the number by which you can, or grade by which you can understand that the property of that particular part, the pounder. Okay, that is the coarse, fine or super fine. For the actually you can think like that way. Market valuation or any kind of you can call commercialization or normal lab, you can consider like that way. This kind of pounder is very much important. The grade of the pounder is very important. By the grade you can understand which one is very fine, which one is moderately fine. So you have to little bit remember. I won't say you that you have to remember everything. At least coarse, fine and super fine, you can just remember those things. Okay, sieve through which all particle must pass, and sieve through all the particle, 40% of the particle can pass. Okay, so okay, now sieve means what? Sieve, I think you have already the studied and you have done the practical. Sieve size, lot of sieve size like 18 number of mesh, 22 mesh, 16 mesh, 60 mesh, lot of mesh is there. So coarse fine means all the particles or all the powder that can be passed through the all the 10 means you can consider like 10 sieve means in 1 square meter 10 pore will be there, like that. Okay, 22 means obviously the size will be little bit lower, less. Okay, the size of the diameter of every pore size will be little bit less compared to 10. So that is the things. Okay, 90% pass through the 10 micrometer. Matlab that is super fine. Okay, so those are the mesh size, and accordingly you have to remember the grade of powder. Coarse powder means that can pass through number 10 mesh or number 10 sieve, not the mesh, that is the sieve. Number 10 sieve, all the coarse powder can be passed. Okay, so you can remember by that way. These things you have understood or not, maybe those who have not attended the previous classes, they have some kind of problem, but that's why I asked you different times. Okay, that's 10, that acha, one basic things I'm asking. Okay, one basic thing I'm asking, then I think that will be properly understandable. Okay, number 10 and number 120, so which one will be more smaller in size, pore size? Basic idea.
120, sir.
120, 120.
Because I have already
120,
said,
120.
yes. Because I have already told, if it is like a sieve, if it is on a sieve, so I have already told in per square meter, unit square meter, if you visualize that, per unit square meter 10 pore will be there, so you can say like 10 sieve. I'm just giving you one basic idea. And if the same area, same like this is one 3 semi-squares, the circle surface area. Okay, in the same area, if it is 120 pore is there, that is 120. Now the question is that same surface area 10 pore is there, and again the same surface area 120 pore is there. Obviously, so 10 means like that way, 10 little bit bigger size, but 120 pore in the same surface, obviously that will be very tiny particle. Sorry, not the particle, tiny size pore. So that is the basic idea. In same constant surface area, 120, the pore size or pore is there. In the same surface area, 10 pore is there in a particular sieve. So by that you can understand. And coarse particle means obviously the size will be big. Sorry, the size will be little bit big compared to the fine product. So that's why they are saying 10, that sieve, in that particular sieve they can pass through. But when you consider the 44 sieve, you can see not more than 40% particle can pass. That is the difference, because those are the coarse particle. They would get stuck. 44 means what? Obviously in the particular surface area 10 was there, now 44 pore is there. Obviously the size will be little bit less, and if the size is little bit less, coarse particle the same big size, obviously all the coarse particle cannot go pass through. So that's why they are saying 40%. And superfine means 90% of the particle can pass through the 10 micrometer. 10 micrometer. Achha, I will just try to hide it here. 10 micrometer. Okay, try to understand. 10 micrometer. Very fine microfine मतलब 350 मेस. 350 मतलब जो 120 मेस सीप जो होता है ना, उसका मेस होता है 350. ऐसे करके तुमको याद रखना होगा, ठीक है ना? 120 मतलब जो सेम सरफेस एरिया, instead of 10 pore, 120 pore will be there. मतलब very fine particle also can the pass through. Okay, so that is the grades of powder, and according to the different sieve size. So you have to remember that thing. Okay, grade of powder. Okay, so these are the topics and these are the content from the micromeritics. Okay, so I have already covered. Okay, I'll take the test. Okay, I'll take the test probably this Sunday if possible, otherwise in the mid of the week. Okay, so particles, all those things I have already discussed. Okay, and if I say which are the important, I hope that everyone is noting down all these things, writing down the things that I am telling you. I have said it multiple times that please maintain copy, otherwise you will be get confused, because nowadays your semester is ongoing right now. Okay, so it is very tough to you to compile all those things in a simultaneous. So that's why I'm just telling you that make one copy, so that after 2 months, after 3 months, if you see it, you can remember a few points. Okay, I am saying you little bit point that from where actually previously questions have came. So we have to more focused on this particular things. Just write it down. All the things I have discussed, but little bit important area. That's why I'm just saying you just write it down. Like determining the surface area, all that things. Anderson apparatus phenomena. Okay, Anderson apparatus phenomena, and these things I am saying you, these things is very important. These things, those who are not there, please see the video, these things, this table, statistical diameter, these things is very important, I am saying you. Okay, 2020 2029 sorry, yes, 2019 questions have came from here, 2019. Okay, so this is the things. And Anderson aperture 2021, the questions have came. Acha, angle of repose, Cars index, every year like 2018 angle of repose questions have came. Cars index 2018 questions have came. 2019 same Cars index questions have came. So that's why I'm telling you, those last topic is very important. Okay, now the things that I'm saying you, n value already I have told. Yeah, n value I have already told, that is not important right now. Okay, now the things is that specific surface area I have already told. Okay, I'm just saying you one second. Okay, yes, that is the things. Okay, yes, that is Martin, Ferret and projective diameter. Okay, this diameter definition you have to remember. Okay, got the point? Okay, after that sedimentation, Stokes law, that is important. Coulter counter method, that principle. Okay, that principle you have to remember. And the surface area determination is जो हम लोग already discussed, surface area determination, that's two things. That two things is very important, absorption method and air permeability method. Okay, 2022 from QuantaSorb the questions have came. You can see, I have just telling you after analyzing, I'm not saying I say it, ठीक है ना. 2022, so the QuantaSorb, that's why I'm telling you, QuantaSorb question have came. So maybe Fisher subsyscizer the questions may come in upcoming days. Okay, the equation, Brunner, Emmett, Taylor, Krosny-Karman equation. So those are the important topics. Okay, that's why I'm telling. Otherwise, there is nothing to mention all those things. There's porosity portion. Okay. Then the all the table I have discussed today, please try to remember. As anyhow we can remember after short memory, memory tricks, chart, anything. Okay, so that is the topics from Micromeritics. So if you have any doubt, you can tell. And I think it is 8:48. No worry, obviously I will take another 30 minutes for the surface and interfacial tension, very basic things. But before that, I will ask some kind of MCQ. I have already told you. So but
দাদা বলছি তোমার ভয়েসটা ব্রেক করেছিল, কিছু শোনা যায়নি।
কিছু শোনা যাচ্ছে না? কতক্ষণ থেকে বল? কখন থেকে শোনা
ওই তো
যাচ্ছে?
পোরোসিটির ওখান থেকে বলছিলে।
মানে আমি যে ইম্পর্টেন্ট কোথা থেকে এসছে এগুলো কিছু শুনতে পাসনি কোন ইয়ারে?
না মানে পোরোসিটিটা বলছিলে ইম্পর্টেন্ট, যে আজকে যেগুলো পড়ালে সেগুলো তারপর থেকে শোনা যায়নি।
ওকে, এই যে কোয়ান্টাসার্ভ যে বললাম ওগুলো কিছু শুনতে পাসনি না? কোয়ান্টাসার্ভ আচ্ছা
হ্যাঁ, ওটা শোনা গেছে। কোল্টার কাউন্টারের প্রিন্সিপাল বললে তারপর।
ওকে আচ্ছা, প্লিজ এভরিওয়ান কনফার্ম মি. ওকে, PL have already said, but I think everyone please confirm what is the status. Sion
একটু আগে ট্র্যাক করছিল, এখন বোঝা যাচ্ছে।
Didis, have you heard what I have told you? I mean regarding all the important area.
Yes.
No, sir.
Okay, the voice is breaking, right?
Your voice is breaking, sir.
Okay.
Yes,
Okay.
sir. It's voice.
Okay, so I just again telling you all these things that lastly I have told that from the surface area determination 2022 the QuantaSorb the questions have came GPAT. Okay, so that's why I'm telling maybe the Fisher subsyscizer for air permeability method the questions may come, and the principle or equation used like Poiseuille or the Krosny-Karman equation. I have already discussed the Krosny-Karman equation. Okay, so that I'm telling only that things. Okay, that this portion is important, and after that the porosity. Okay, the packing arrangement percentage, that is important, and all the table that I have discussed today. Got my point or not? Have you understood or have you heard properly it? Anyone please confirm.
হ্যাঁ
Yes,
দাদা
sir.
I
হ্যাঁ দাদা
don't know the previous from the previous classes why the network issue is that much. But compared to the previous classes, I think little bit good today, isn't it? আগের দিনের থেকে তো একটু ঠিকঠাক রয়েছে নাকি? হ্যালো?
হ্যাঁ দাদা আজকে আজকে অনেক ক্লিয়ার, হ্যাঁ আজকে অনেক ক্লিয়ার।
Okay. Fine. So, okay. I am just asking you the questions, okay? It will better you just write in the chat box, okay? If you just write in the chat box and I will ask particular person to explain, okay? Little bit. Don't just get fear. I'll just ask little bit because MCQ I will ask because no, written format is not there, okay, in the slide. So I will ask verbally. So why it is taking that much time? Okay, now it is properly. So the first question is, that is a very easy question, that is not that much of tough. Acha, what does micromeritics, try to understand the questions very easily, okay? What does micromeritics affect or mainly affect in dosage forms? What does micromeritics mainly affect in dosage form? So the dosage form can be anything. So the options are drug stability, drug release, drug absorption, drug solubility. What does micromeritics mainly affect in dosage form? Mainly affect in dosage form. So try to understand. Yes. Hello.
Sir, can you repeat the question?
Yes. I am asking you that what does micromeritics mainly affect in dosage form? Dosage form में उसका मतलब influence क्या है?
ড্রাগ সলিউবিলিটি,
To my of course. Yes. Okay, fine. Yes, the question is little bit tricky actually. Drug solubility, drug absorption, drug release and drug stability. All these things are there, okay? But the things is that I am asking the questions from that purpose because I can remember in the class I have said if the particle size is small, the surface area will be increased, solubility will be better, consequently the bioavailability will be more. That is fine. But here the questions you can follow a little bit wisely, that they have mentioned mainly, they have actually precise or give some kind of importance on the dosage form. So different types of dosage forms is there, right? Tablet, capsule, all those things. But the things is that release kinetics, I think you have heard or not, release, drug release is very, very important. Drug release is very important. So from one dosage forms, solubility will be obviously important, but solubility will be later. First of all, drug have to be released. Okay, na? Drug have to be released from the core of the material. It may be any kind of tablet, any kind of capsule. So first the drug have to be released. So if the micromeritics or the particular size, all those things is not proper, flow property is not proper, okay, I have already discussed. So drug release will be very difficult. So if the drug cannot release properly, so then how it can flow, soluble or dissolve well, how it can go to the particular target site, isn't it? So for that reason, if the question is come like that way, maybe little bit confusing, but mainly if you consider one dosage form, you have to say drug release, because drug release is actually directly depend on the micromeritics, mainly the powder shape, powder size, all these things, okay? So drug release will be important here, okay? Okay, ठीक है, अच्छा. Then I just want to know from you one basic, that is also very basic things, that what is the disadvantage of sieving method? Sieving method of you, all of you have heard, right? But what is the disadvantage of sieving method? Option A, agglomerates can be identified. Option B, attrition of particle during sieving may lead to size reduction. C, option A and B, matlab both A and B, as D, none of the above. So what is the disadvantage of any kind of powders or granules?
দাদা শোনা যায়নি কোশ্চেনটা, ভয়েস ব্রেক হচ্ছিল।
দাদা কোশ্চেনটা রিপিট করো, কোশ্চেনটাকে রিপিট করো।
Yes. I am saying what? Acha, voice is breaking, na? Voice is breaking, right?
Yes, sir.
Okay, I am saying that what is the disadvantage of sieving method? सिविंग मेथड उसका डिसएडवांटेज क्या है, मैं यही पूछ रहा हूँ कि एग्लोमरेट कैन बी आइडेंटिफाइड, disadvantage I am telling you, okay, agglomerate can be identified, b attrition of particle during sieving may lead to size reduction. Option C both A and B, option D none of the above. Now we have understood or not, please clarify me.
স্যার কোয়েশ্চেনটা ক্লিয়ার শুনতে পেলাম না।
কোয়েশ্চেনটা শোনা যাচ্ছে না তো।
Okay, I got okay, just let me rejoin, okay, I have just understood.